Welcome to Module 2, Solution Architect Series, Power Platform Architecture. This module is part of the Solution Architects Design Microsoft Power Platform Solutions learning path. Let's get started. Solution Architecture Series, Power Platform Architecture. Introduction. A solution architect for Microsoft Power Platform is responsible for overall design of the solution. Understanding the architecture of Microsoft Power Platform, how it's designed, and its limits are important when designing solutions based around Microsoft Power Platform. As you consider your solution's design, you need to understand the components and capabilities of Microsoft Power Platform and how they control the design of your solution. Microsoft Power Platform Components. Microsoft Power Platform is a low-code, rapid business application development platform, and it contains several different independent yet closely related tools. Microsoft Power Apps allows anyone to build custom web and mobile apps by using low-code or no-code techniques. Microsoft Power Automate, a cloud workflow tool to connect cloud and desktop applications together and automate business processes. Microsoft Power BI, a self-service analytics service that allows users to gain insights into their data. Power BI allows you to merge data from various sources and to create models, visualizations, reports, and dashboards. Microsoft Power Virtual Agents, now Microsoft Copilot Studio, allows anyone to create chatbots or copilots without writing code from within a browser interface. Microsoft Power Pages allows anyone to create external-facing websites that allow users outside their organizations to create and view data in Dataverse. Microsoft Power Platform includes many other components that support Microsoft Power Platform tools that the solution architect can use. Microsoft Dataverse provides a no-code environment to create tables, relationships, and business logic. Data connectors. Connectors define the services and data sources that Microsoft Power Platform tools can access. AI Builder, a set of AI model types that can use data in Dataverse to create, tailor, and train AI models that can be used by other components of Microsoft Power Platform. The following diagram illustrates how Microsoft Power Platform components are related. Note, this module describes the architecture of Microsoft Power Platform. Other modules will examine the details for Power Apps, Power Automate, Power BI, Power Virtual Agents or Copilot Studio, and Power Pages. Cloud. Microsoft Power Platform is cloud-based software as a service (SaaS) solution that is available from within a Microsoft Entra ID tenant. Microsoft Power Platform is licensed through Microsoft 365 and secured by Microsoft Entra ID. Microsoft Power Platform runs on Microsoft Azure, therefore it's highly scalable and available globally. Microsoft Power Platform capabilities. Typically, the solutions that a solution architect designs use many components that are provided by Microsoft Power Platform. The individual components provide great capabilities on their own, but are more powerful when combined. Power Apps allows users to action data and drive business processes. Power Automate can automate apps and act on behalf of the user in response to metrics and events. Power BI can analyze the data that is captured by apps. Power Virtual Agents can assist users. Power Pages can interact with external users. Power Automate flows can be called from Power Apps, Power Virtual Agent actions, and Power BI alerts. Power BI dashboards and tiles can be displayed in Power Apps screens. Power Apps can be embedded in Power BI dashboards. Meaning of platform. Typically, when most people refer to Microsoft Power Platform, they're thinking of four components: Power Apps, Power Automate, Power BI, and Power Virtual Agents, or Copilot Studio. These tools allow you to build apps and create solutions. Data is at the center of everything that businesses do today. With Microsoft Power Platform, you can connect to data where it lives by using connectors or store data in Microsoft Dataverse. Connectors are provided for the following entities: Office 365 services such as email and SharePoint, now Microsoft 365. Azure services such as Azure SQL, Non-Microsoft sources such as Twitter, X, SendGrid, Dropbox, and MailChimp. Power Apps and Power Automate use the connectors to access the data where it lives. Microsoft Dataverse is more than a database. It's a platform for building business apps and solutions. Microsoft Dataverse controls security, implements logic, enables integrations, and contains a wealth of capabilities that enable powerful business solutions to be created. These capabilities are explored further in this module. Before taking an in-depth look at Dataverse, you first need to learn how Dataverse is accessed through environments. Next unit, environments. Environments. An environment is a space to store, manage, and share an organization's business data, apps, and flows. Administrators can create environments and control access to environments. An environment has the following components. Name of the environment. Location, which Azure region that the environment, its data, apps, and flows are stored in. Admins, who can manage the environment. Security group, controls which users can access the environment. Apps that are created in the environment. Flows that are created in the environment. Bots, chatbots that are created in the environment. Connectors, custom connectors that are added to the environment. Gateways, on-premise gateways that are connected to the environment. Dataverse, optional, an instance of a Dataverse database. Environments are containers that administrators can use to manage apps, flows, connections, and other assets, along with permissions to allow organization users to use the resources. Tenants. Microsoft 365 uses a Microsoft Entra ID tenant to control authentication and authorization. You don't need an Azure subscription to access Microsoft Entra ID. The Microsoft 365 subscription permits access to the Microsoft Entra ID portal. Adding a user to Microsoft 365 will add the user to Microsoft Entra ID. Additionally, Microsoft Entra ID tenants are located in an Azure region, which is typically the region of the user who created the tenant. Environments are created within a Microsoft Entra ID tenant. Access to the environment is authenticated by Microsoft Entra ID. Multiple environments. An environment is a container to separate apps that might have different roles, security requirements, or target audiences. How you choose to use environments depends on your organization and the apps that you're trying to build. For example, you can choose to only build your apps in a single environment. You might create separate environments that group the test and production versions of your apps. You might create separate environments that correspond to specific teams or departments in your company, each containing the relevant data and apps for each audience. You might also create separate environments for different global branches of your company. The following diagram illustrates how an organization might create multiple environments. Environments are a scope for lifecycle management and a scope for permissions. Items not contained in an environment. Environments contain Microsoft Power Platform components such as apps, flows, and bots. However, not everything that you might build for your solution is contained in environments. Microsoft Dynamics 365 apps, sales, marketing, customer service, field service, and project operations are contained in an environment. No limitations are applied to the number of apps or flows that can be deployed within an environment. An environment does not contain Power BI workspaces, datasets, reports, or dashboards. An Azure service that is deployed. Non-customer engagement Dynamics 365 apps, for example, Finance or Business Central. A solution architect needs to consider how access to these other components is controlled. The following diagram illustrates how an environment is related to other components inside and outside the environment. Security layers. Microsoft Power Platform uses multiple layers of security. Microsoft Entra ID, user identities, are authenticated by Microsoft Entra ID. With Microsoft Entra ID, you can restrict people from using Microsoft Entra ID features, such as conditional access policies, and enforce security through multi-factor authentication. Microsoft Entra ID supports single sign-on, SSO, so that users don't need to sign in separately to Microsoft Power Platform. Guest access is supported for Microsoft Power Platform. Licensing. Users require an appropriate license to access Microsoft Power Platform. Environments. Microsoft Entra ID security groups control access to each environment. Data loss prevention policies restrict the use of connectors for environments and therefore the risk of data leakage. You can create cross-tenant inbound and outbound restrictions where you have a multiple tenant scenario. Security roles. Access to tables and rows in Dataverse is controlled by security roles. Encryption. All data is encrypted at rest by using SQL Server. Transparent data encryption, TDE. All data is encrypted in transit by using SSL. The following diagram shows how security layers are applied for Microsoft Power Platform environments. Layers of security: encryption, security roles, data loss prevention policies, environment, license, Entra ID. When creating an environment, the solution architect needs to decide the location of the environment. Next unit, environment data location. Environment data location. Microsoft has a worldwide network of data centers which support Microsoft Power Platform that are set up in 17 different locations. This level of localization helps organizations more easily meet data residency, sovereignty, and compliance requirements. When creating an environment, you can specify its geographical location. The data for the environment will be held in the chosen geographical location. Note: an environment can be relocated after it has been created, but it is easier to select the correct region from the beginning. Regions. Microsoft offers the option of choosing global, local, and sovereign clouds. Global cloud. A public internet cloud deployment option that lets customers access globally connected cloud services that are deployed from regional Microsoft data centers. The global clouds are United States, Europe, and Asia Pacific. Local cloud. A cloud option that addresses local data residency requirements by letting all public cloud users within a country or region keep their data in the country or region. The local clouds are Canada, Brazil, United Kingdom, France, Germany, India, Japan, Australia, United Arab Emirates, Switzerland, and Republic of South Africa. Sovereign cloud. A cloud option that adheres to the strictest standards of operation. Data remains inside the country or region of residence always. Sovereign clouds are US government and China. Note: new locations are planned, so the preceding list might not be complete. You can check out the availability for latest information. The following diagram shows the supported Microsoft Power Platform locations. Data residency. Ask yourself the following question to determine which of the several aspects influence the choice of location for environments and data. Are the users geographically dispersed? What latency is acceptable? Does the organization have separate autonomous business units where data must not be shared? Are the required features available in the region? Are security requirements in place that should be considered? Are specific data and compliance requirements in place? If no other factors exist, you should select a location close to most users who need to share data. Note: the location of the tenant, billing, can be different from the location of an environment and its data. Compliance and data protection. Solution architects must consider regulatory and compliance requirements such as the General Data Protection Regulation, GDPR, when deciding on a location for the environment and data. Microsoft won't transfer customer data outside the selected Azure geographic location, or GEO, except when it's necessary for Microsoft to provide customer support, troubleshoot the service, or comply with legal requirements. Microsoft Power Platform stores information that is global in nature, such as user identities and profile information, in a data center that is located in the United States. All Microsoft Power Platform customers' data and the geo-redundant mirrors are maintained within the selected geo. When to use multiple environments. A previous module explained how Microsoft Power Platform uses environments to separate development from production and to separate different user groups. When you further consider the location of users in a global organization, consider other reasons for creating multiple environments. Handle application lifecycle management, ALM, dev, test and prod. Isolate resources that aren't used by the same users or that share data. Allow conflicting customizations between different regions or markets, or for compliance with legal and regulatory constraints. Keep environments close to users who don't share data. Isolate data that can't be co-located. Provide places for makers to experiment. The next unit will explain how you can work with the data. Managed environments. Managed environments offer a set of enhanced out-of-the-box governance capabilities that simplifies, automates, and streamlines IT administration of Microsoft Power Platform at scale. Once an environment is enabled as a managed environment, you can limit sharing, reduce risk by limiting how widely Canvas apps can be shared, view usage insights, include insights for the environment in a weekly email digest, data policies, limit the connectors available, set up Power Platform pipelines, easily deploy solutions between environments. See Managed Environments overview for further details. Landing zones. Power Platform landing zones is a reference architecture and design methodology that consists of design principles to serve as a compass for organizations to determine their overall architecture for Microsoft Power Platform. It enables effective construction and operationalization of landing zones, environments, on Power Platform at scale. This approach aligns with the platform and product roadmap and the Center of Excellence adoption framework. The following diagram shows the high-level architecture for Power Platform landing zones. Power Platform landing zones architecture contains critical design areas with heavy interrelated and dependent design decisions, licensing and AD tenants, identity and access management, security, governance and compliance, environments, management and monitoring, business continuity and disaster recovery, connectivity and interoperability, platform automation and DevOps. The methodology can be used for both new Microsoft Power Platform organizations and for those who already have implemented Power Platform solutions. The solution architect may not be responsible for implementing environment strategy, but if there's no strategy, the solution architect should use the design principles and considerations contained in Power Platform landing zones. See the Power Platform landing zones GitHub repo for further details. Connecting to on-premise networks. For some organizations, a secure connection between the end user on-premise locations and Power Platform services is required. You can use Virtual Private Networks, VPN, or Azure ExpressRoute. Microsoft Azure ExpressRoute provides a way to connect your on-premise network to Microsoft Cloud services by using private connectivity. The following diagram shows the ExpressRoute network configuration. The benefits of using ExpressRoute for your organization are compliance. You won't route customer information via the public internet. Predictability. Having a dedicated connection avoids conflict with other internet traffic. See Use Azure ExpressRoute with Microsoft Power Platform for further details. Other networking considerations may concern accessing data held in on-premise locations. The on-premise data gateway enables you to connect Power Platform apps and flows to on-premise data sources. The following diagram shows the on-premise data gateway network configuration. Next unit, work with data. Work with data. Data is at the center of everything that a business does today, and it powers the insights that can drive what the business should do tomorrow. To thrive and grow, businesses need to capture, analyze, predict, present, and report data, and do it all with a high level of agility. With Microsoft Power Platform, you can access data from the platform by using connectors, store data in the platform by using Microsoft Dataverse. APIs. Microsoft Power Platform uses REST APIs to communicate between apps and data to perform management activities. REST APIs are built on open standards. You can compose HTTP requests for specific operations or use libraries from other sources to generate classes for whatever language or platform you want. Connectors and Dataverse use REST API and OData for requests and data. Dataverse versus connectors. Connectors allow you to take advantage of Microsoft Power Platform without moving your data. Power BI, Power Apps, and Power Automate use connectors, which allows you to analyze, act, and automate across data and services. With connectors, you can use existing data sources and services, connect to more than 400 systems and services out of the box, access data that is stored on-premise in systems with Data Gateway, create custom connectors for internal services and services from other sources. Important: not all public connectors support all actions that the underlying service supports. Solution architects should investigate to ensure that the actions they require are supported, otherwise a custom connector is required. Connectors allow you to build your apps without having to migrate the data, which can be time-consuming or costly. Microsoft Dataverse should be your data source of choice for new data stores or where you want to use Dataverse capabilities, which will be described later, or features of Microsoft Power Platform such as AI Builder or Power Apps Portal Apps. Custom connectors. In situations when a connector isn't present but the service has a REST API, a custom connector can be created. Creating a custom connector is straightforward, with several different methods for defining the custom connector, including importing the Open API definition to describe an existing API, creating a Microsoft Azure Functions solution, and then using Microsoft Azure API Management. Create a custom API to define your own actions. Note, many other services will push an Open API definition for their full API. Custom connectors support OAuth, including Microsoft Entra ID, API Key, and basic authorization. Custom connectors can be packaged and deployed with solutions. Actions can help make it easier for makers to invoke complex custom logic. For example, consider the following process steps to register a student for a class. Check if the student exists in the registry. Add the student if they aren't shown in the registry. Look up the class by using a course code. Check if the class is over capacity. Check if the student meets class prerequisites. Create a class record for the student. Notify the user of the results. You could create a custom connector for the learning service with an action called Register Student for Class that performs these steps as shown in the following image. With a custom connector or API, student details as the input, register student for a class action as output, a student ID. All done within the learning service. Makers without the custom connector would need to know the details of the service. Using a custom connector with an action promotes good architectural design. Loose coupling and could occur in a contract where the calling system doesn't need to know the details because they could change. Microsoft Dataverse capabilities. Microsoft Dataverse is more than a database. Dataverse includes many features that make building business solutions easier and provide enhanced functionality. The following diagram illustrates the capabilities that are provided by Microsoft Dataverse. Security, logic, data, storage, and integration. The solution architect needs to understand the capabilities of Microsoft Dataverse and how these can be applied when creating solutions. Because Dataverse is built on Azure, it benefits from the Azure platform's powerful security technologies. Encryption of the data at rest and in transit preserves confidentiality. Dataverse uses Microsoft Entra ID identity and access management mechanisms to help ensure that only authorized users can access the environment, data, and reports. Dataverse uses role-based security to group together a collection of privileges. These security roles can be associated directly with users, or they can be associated with Dataverse teams and business units. In Dataverse, individual rows can be shared on a one-by-one basis with another user. Because row-level control of access isn't adequate for some business scenarios, Dataverse has a column-level security feature to allow more granular control of security at the column level. Dataverse also includes security models that can be used for hierarchies, the manager hierarchy and the position hierarchy. The security model that Dataverse provides is highly configurable. Several choices are available for applying custom business logic in Dataverse, including business rules, classic workflows, and Power Automate. Calculated columns and roll-up columns reduce the need for processing and custom code. Dataverse has built-in functionality for duplicate detection and to delete stale data. All components that are created in Dataverse are held as metadata, meaning that the components are discoverable and that the properties for components are accessible to applications and tools. This metadata is used by Power Apps and Power Automate, reducing the effort that is required to create apps and flows. For example, the data type of a column and its range of possible values are held in metadata. In this example, Power Apps Studio is able to access this metadata and automatically configure the control when a column is added to a form. The data that is held in Dataverse is abstracted from the underlying data storage mechanism. The data could be stored in the Elastic Database feature of Azure SQL Database, Azure Storage, Azure Cosmos DB, or Azure Data Lake Storage. The maker doesn't have to concern themselves with the storage. They can access the data through the APIs that are provided by Dataverse. Microsoft decides how to store data differently depending on type, for files, images, and text. Dataverse provides an event model for integrating with other systems, and import and export data processing capabilities are provided. Dataverse uses Microsoft Azure Cognitive Search to enable data that is held in Dataverse to be searched. Dataverse isn't restricted to apps that are built with Microsoft Power Platform. The APIs allow applications to be built with other tools such as Xamarin to build an external, customer-facing application. Reasons for choosing Dataverse. Building the data infrastructure to enable business insight can be time-consuming and expensive. The data originates from various devices, applications, systems, services, and software as a service, SaaS. This large and growing number of sources often consists of multiple data technologies that store different types of data, exposes different APIs, and uses a mixture of security models. The developers that are needed for creating these technologies can be expensive and hard to find. Often, developers must have a deep understanding of how to deploy, configure, manage, and integrate these different data technologies. Dataverse addresses these concerns with a user-friendly, manageable, compliant, scalable, and globally available SaaS data service. Dataverse empowers organizations to work with any type of data and any type of app and then use the data within it to gain insights and drive business actions. As part of Microsoft Power Platform, Dataverse requires no or little code to be written, so it can be used by anyone, from knowledge workers to professional developers. Standard and custom tables within Dataverse provides a cloud-based storage option for your data. Tables let you create a business-focused definition of your organization's data for use within apps. If you aren't sure whether Dataverse is your best option, consider these benefits. Simple to manage. Metadata and data are stored in the cloud. You don't have to be concerned about details of how they're stored. Simple to secure. Data is stored in a way that users can see it only if you grant them access. Role-based security allows you to control access to tables for different users within your organization. Access your data. Data from your Microsoft Power Platform applications is also stored within Dataverse, allowing you to quickly build apps that use your data. Rich metadata. Data types and relationships are used directly within Power Apps. Logic and validation. Define calculated columns, business rules, workflows, and business process flows to ensure data quality and drive business processes. Productivity tools. Tables are available within the add-ins for Microsoft Excel to increase productivity and ensure data accessibility. Virtual tables. One further option for accessing data is by using virtual tables. Consider the requirement to access data from an external data source and then combine it with data in Dataverse. Virtual tables allow you to create a virtual table in Dataverse, define an external data source, and then map the table and columns onto the external data source. An OData v4 data provider configuration is included with Dataverse that allows you to connect to an external OData v4 web service. A data provider for Azure Cosmos DB for NoSQL is in preview. Note: Dataverse requires that all tables have an ID attribute. This ID is known as a unique identifier and the value must be a GUID. You can only map ID columns to external columns with the edm.GUID data type. Hence, the external web service must use a GUID as its ID column. See virtual tables for more information. Virtual table connectors. Creating virtual tables can be complex and require plugin code. Microsoft is introducing a new method for connecting Dataverse to external data sources. Virtual table connectors. Virtual table connectors streamline the creation experience by automating some of the creation for you and removing the need to use code to create the virtual tables and their processing of data. This is currently in preview and limited to SharePoint and SQL Server. See Create Virtual Tables using Virtual Connector Provider for more information. Extensibility model. Everything in Microsoft Dataverse is exposed as an API call. All tools and apps can be accessed through the Web API as shown in the following diagram. Dataverse provides extension capabilities at every horizontal layer. As a solution architect, you need to understand the different types of extensibility paradigms. Dataverse has the following features: a rich API for integrating with web services and OData. No-code logic with business rules, calculated columns, roll-up columns, business process flows and more. Developer support with full .NET SDK with access to the transactional pipeline. Client-side scripting with TypeScript and JavaScript. Integration with Microsoft Azure Service Bus and Microsoft Azure Event Hubs. Custom actions and custom APIs. These capabilities allow complex enterprise applications to be built by using Microsoft Power Platform. Though the solution architect might not have been a developer, they need to be familiar with each of these points and how they can be used in solutions. Dataverse API. The Dataverse Web API provides a development experience that can be used across various programming languages, platforms and devices. The Web API implements the OData version 4.0, an OASIS standard for building and consuming RESTful APIs over rich data sources. The Web API provides a modern, RESTful web service that you can use to interact with data and metadata in Microsoft Dataverse by using various platforms, programming languages, and devices. Note: when you are using Dataverse connectors in Power Automate and Power Apps, they are making calls to the OData API. A developer can add custom plugin logic at the pre- and post-operation stages of a transaction to perform validation calculations and integrations by using the .NET SDK. Note: the App API is also exposed to a SOAP endpoint. The SOAP endpoint is deprecated and should not be used directly for new apps. Custom APIs. Dataverse enables you to create your own APIs in Dataverse. You can consolidate one or more operations into a custom API that other developers can call from Power Automate Cloud Flows or integrate with instead of using the Dataverse Create, Read, Update APIs. You can catalog custom APIs as business events to enable creating integration capabilities such as exposing a new type of trigger event in the Microsoft Dataverse connector. The next unit explains how to create custom logic. Custom logic. Microsoft Dataverse provides many different ways to perform custom logic. Several options are available for applying custom business logic in Dataverse, including business rules, classic workflows, Power Automate cloud flows, business process flows, calculated columns, roll-up columns, plugins, custom workflow assemblies, custom actions, custom API, client-side scripting, Power Apps Components Framework code components, Azure Service Bus and Event Hubs integration, and webhooks. Create custom logic. The solution architect will need to be able to decide which components of Microsoft Power Platform is used and where it is used in the solution. No rules are imposed for this decision because each option has its own pros and cons. For instance, the following limitations can occur. You can't trigger Power Automate flows from calculated or roll-up columns. Roll-up columns are only recalculated every hour. Business rules can only access the columns on the form for its own table. Classic workflows can't access rows in one-to-many relationships. Data that is changed by a business rule will not trigger an onChange event that was created with JavaScript. This list of limitations is not exhaustive. Having a no, low code or a code-first approach is not the correct tactic. You need to decide each situation on its own merits. Understanding the capabilities of these options is a prerequisite for an aspiring solution architect. Synchronous versus asynchronous processing. Custom logic can be implemented synchronously or asynchronously. Solution architects need to consider whether custom logic operations should be performed synchronously or asynchronously. Synchronous. Save the record. Operation 1, Operation 2, Operation 3, and at the end of Operation 3, a user sees the results. Asynchronous. Save the record. User sees the results. Operation 1, 2, and 3 run concurrently. When operations are performed synchronously, user's screen is blocked until all operations are completed. The operations can modify data before or after it is saved to the database. Synchronous calls add minimal overhead to handling the processing, but all operations in a synchronous transaction are limited to a total of 2 minutes. This limit is fixed and can't be changed. Dataverse plugins and classic workflows can be performed synchronously. Business rules are performed synchronously if the scope is set to table. When the operations are performed asynchronously, the user screen is returned after their data is saved to the database. The operation will be added to a queue and will be performed at a later point in time, which could be within a few seconds, several minutes, or even hours, depending on the workload. Asynchronous means that users will have to refresh their screen to see the results. Additional overhead occurs in running asynchronous jobs. The platform creates rows in the async operation and workflow log tables. These rows are updated when the operation starts, as it progresses and after it completes. The rows can be set to be automatically deleted. Dataverse plugins and classic workflows can be performed asynchronously. Power Automate cloud flows are performed asynchronously. Client versus server processing. Solution architects need to understand where logic is performed. Canvas app formulas, model-driven form script, business rules, and Power Apps Components Framework logic happens in the user interface, and the user will see the results immediately. However, the logic is only enforced in the app in which the logic is implemented. Plugins, Power Automate cloud flows, classic workflows, and business rules with scope set to table happen only when the data is sent to the server by an app, flow, or an API call. The user only sees results of service custom logic in their app on refresh of data. Server logic is enforced when any app, flow, or API is used. Microsoft Power Platform imposes limits on the number of calls that can be made. The solution architect needs to design the solution with these limits in mind. Next unit, platform limits. Platform limits. The platform doesn't provide an infinite amount of resources, and limits are imposed on the number of API calls that can be made. A solution architect needs to ensure that the solution doesn't exceed the limits that are imposed by the platform by designing appropriately and ensuring that custom code can handle when limits are breached. API requests. Requests in Microsoft Power Platform consist of various actions that a user makes across various products. The following list describes what constitutes an API request at a high level. Power Apps. All API requests to connectors and Microsoft Dataverse. Power Automate. All API requests to connectors, HTTP actions, and built-in actions from initializing variables to a simple compose action. Both succeeded and failed actions count towards these limits. Additionally, retries and other requests from pagination count as action implementations. As a basic rule, each step in a Power Automate cloud flow is an API request. Dataverse. All create, read, update, and delete CRUD, assign and share operations including user-driven and internal system requests that are required to complete CRUD transactions, as well as special operations like share or assign. These requests can be from any client or application and can use any endpoint. These requests include, but aren't limited to, plugins, classic workflows, and custom controls that are making the previously mentioned operations. Entitlement limits. Entitlement limits represent the number of API requests that users are entitled to make each day. The allocated limit depends on the type of license that is assigned to each user. API entitlement limits are based on a 24-hour period, as shown in the following table. Product. Paid license users for Power Platform excludes Power Apps per app, Power Automate per flow, and Power Virtual Agents, and Dynamics 365 excluding Dynamics 365 team member. Requests per license per 24 hours is 40,000. Power Apps pay-as-you-go plan and paid licensed users for Power Apps per app, Microsoft 365 apps with Power Platform access and Dynamics 365 team access. Requests per paid license per 24 hours, 6,000. Power Automate per flow plan, Power Virtual Agents base offer, and Power Virtual Agents add-on pack. Requests per paid license per 24 hours, 250,000. Paid Power Apps portals sign-in, requests per paid license per 24 hours, 200. Dataverse provides the ability to have identities that don't require a user license to interact with the service. The 4 types of users are application users, non-interactive users, administrative users, and system user. Each tenant has a base request capacity for each tenant that can only be used by these users and are not by users with standard licenses. This base request capacity is based on type of subscription, as follows. If a tenant has at least one Dynamics 365 Enterprise subscription, they get 100,000 requests every 24 hours. If a tenant has at least one Dynamics 365 Professional subscription, they get 50,000 requests every 24 hours. If a tenant has at least one Microsoft Power Apps or Power Automate subscription, they get 25,000 requests every 24 hours. Power Apps and Power Automate Capacity add-on allows customers to increase the limits for a given user. Each capacity add-on raises the request limits by another 10,000 every 24 hours. Note: for more information, see API request limits. Service limits. Apart from the daily API request limit, service protection limits are available that are specific to each service. As with the daily limits, service limits help maintain the quality of service by protecting the service from malicious or noisy behavior that would otherwise disrupt services for all customers. Service protection API limits help ensure that users who are running applications can't interfere with each other based on resource constraints. The limits won't affect normal users of the platform. Only applications that perform numerous API requests might be affected. The limits provide a level of protection from random and unexpected surges in request volumes that threaten the availability and performance characteristics of the Dataverse platform. Microsoft limits the number of concurrent connections for each user account, the number of API requests for each connection, and the amount of runtime that can be used for each connection. These limitations are evaluated within a 5-minute sliding window. When one of these limits is exceeded, an exception will be thrown by the platform. Important: service protection limits can't be increased. Note: For more information, see API limits. Retry policies and patterns. Custom logic that uses the APIs should handle retries. When a service protection API limit error occurs, it provides a value indicating that the duration before any new requests from the user can be processed. The Web API returns a 429 error if the limit is reached. The response includes a retry after, with the number of seconds. With the organization service, a timespan value is returned in the organization service fault.error details collection with the key retry after. Note: care should be taken to ensure that you don't make it worse by over retrying. For more information, see protection limits. Minimize API calls. The solution design must not depend on infinite capacity being available. For normal users of interactive apps, the limits have been set high enough that users shouldn't be affected. Applications that are designed to load data into Dataverse or perform bulk updates must also be able to manage service protection API limit errors. These applications prioritize throughput so that they can complete their work in the minimum amount of time. These applications must have a strategy to retry operations. Portal applications typically send requests from anonymous users through a service principal account. Because the service protection API limits are based on a user-by-user basis, portal applications can reach service protection API limits based on the amount of traffic that the portal experiences. Integrations should be optimized to minimize the number of API calls. The solution architect must also consider high availability in the design of the solution. Next unit, high availability and disaster recovery considerations. High availability and disaster recovery considerations. Solution architects need to consider how to include high availability in the solution design. Microsoft handles availability and disaster recovery for Microsoft Power Platform and its components. The solution architect needs to focus on non-Microsoft Power Platform components, custom code, and integrations. Business continuity and disaster recovery. Microsoft provides disaster recovery for production environments of Dynamics 365 Software as a Service (SaaS) applications and Power Platform environments for business continuity if there's an Azure region-wide outage. Microsoft creates a replica of Azure SQL storage and file storage in the secondary region for each production environment at deployment. These replicas are referred to as geo-secondary replicas. The solution architect should identify and design the business continuity strategy. Note: Power Platform landing zones contain a set of design considerations for business continuity and disaster recovery. Principles of high availability. When creating a solution, the solution architect should follow these principles. No single points of failure should exist. Use the capabilities of Microsoft Azure whenever possible. Use monitoring and health checks to predict and detect problems. Microsoft deploys a Microsoft Power Platform environment within an Azure region. Within a region, services and data are replicated redundantly across the data centers to increase availability. Each Azure region has a paired region where Microsoft Power Platform resources are replicated automatically. Microsoft monitors Microsoft Power Platform on your behalf as part of the service. Handle failover. Microsoft Power Platform components handle internal integrations. Solution architects should focus on external integrations and custom code. If an issue occurs with the primary data center, Microsoft initiates the failover automatically, if necessary, from the primary location to the regional pair. Microsoft also handles required service recovery. Users shouldn't notice interruption in service. At worst, they have a transient error when saving data. For example, model-driven apps handle such errors. However, custom code could have issues. For example, the endpoint for the environment might change. Integrations should use the Global Discovery Service for endpoint discovery to get the latest environment endpoint. Custom code should have transient error handling with automatic retries. Next unit, let's check our knowledge. Answer the following questions to see what you've learned. What should you use to control access to a Power Platform environment? I'm going to say license. Could also be security group. Which components should a solution architect consider for failover if a regional data center failure has occurred? Portal apps, plugins, discovery service, integrations. I'm going to say integrations. You need to migrate millions of rows of data into Dataverse. You are concerned that Power Platform import tools will exceed the limits. What should you do? Use execute multiple requests and batches to import the data. Implement retry loops in the code. Use data migration tool from another source to avoid reaching the limits. Raise a service request with Microsoft to increase the service protection limits. I'm going to go implement retry loops in the code. Let's review the answers. Okay, what should you use to control access to a Power Platform environment? The options were license, sharing, workspace, security group. I went with license, should be security group. You can see the answers there. Let's have a look at the summary. Microsoft Power Platform provides a flexible architecture that can be tailored to support many business scenarios. Staying up to date on Microsoft Power Platform capabilities is essential in designing a solution that will be best use these capabilities. In this module, you learned about Microsoft Power Platform architecture, including key Microsoft Power Platform architecture components, planning for environments, capabilities of Microsoft Dataverse, how service limits can affect solution design. A solution architect needs to make the most of Microsoft Power Platform architecture. Microsoft Power Platform components are designed to work together. Use the platform's strengths rather than focusing on the weaknesses. Use Microsoft Azure to fill gaps where you exceed the platform's capabilities instead of pushing the platform beyond its natural capabilities. Avoid using unsupported techniques for customizations. Consider the performance impact of solution choices. Many tools in Microsoft Power Platform can answer the same question. Choose the tool that maximizes performance and user productivity. A solution architect needs to consider the roadmap that Microsoft publishes twice a year. Understand what is on the roadmap that impacts your solution architecture. Evaluate and decide when to adopt new emerging approaches. Ensure that your solution architecture doesn't use deprecated features. Avoid using unsupported customizations to ensure that fast-paced updates don't impact your solution. Next steps. If you want to learn more about Microsoft Power Platform architecture, the PowerCat team has produced a series of videos on Microsoft Power Platform architecture and best practices. For more information, see Microsoft Power Platform best practices. For more information on Dynamics 365, see the Dynamics 365 Fundamentals Learning Path. The next steps are to look at data modeling in Dataverse. I'll put a link to these URLs in the description of the video. Hope you found this useful. Give it a thumbs up and subscribe to the channel. Thanks for listening.